This short video illustrates the importance of both design and maintenance when installing sand slit drainage in sports fields and golf courses. To do this, we shall use glass-sided tanks filled with two materials, a fine sand and a coarse sand. These will represent our slowly permeable soil and our highly permeable sand slits. Most people turn to sand slit drainage systems when they have slowly permeable soils such as clays and silts. They will behave in the same way as this fine sand, but water will move even more slowly. This next clip shows what happens when we start to add water to the soil. It has been speeded up times 15. When we start to add water, you can see that due to the hydraulic potential, water is pulled sideways into dry pores. This happens nearly as quickly as the vertical movement. When rainfall rates are low, the water moves through the soil slowly and the top of the surface becomes wet. This then causes all sorts of traction and grass wear problems in the pitch or course during play. Let's look at what happens when we increase the rainfall rate. In soils with low infiltration rates, the water starts to pond at the surface and flooding takes place. The pitch then becomes unusable. We can see that once the rainfall stops, the ponding disappears, but the surface is still wet and will still degrade. Of course, in a clay soil this would happen even more slowly, and remember this video is speeded up times 15. One commonly held solution to this problem is adding a sand layer to the surface to help keep the surface dry. The next clip shows why this approach is flawed. Initially it appears that the water is going straight through the coarse sand. But as the slowly permeable soil wets up at the top, the coarse sand becomes saturated and ponding occurs again. This is because the infiltration is being controlled by the fine soil, not the coarse sand. To make the system work, we need to create a conduit for the water to move from the surface to the drainage system at depth and away from the player surface interface. For this we use a sand slit. Water is still being added at the same higher application rate as in the previous clip. In a well-constructed sand slit, we can see the water flowing through the coarse sand into the sand slit. As the fine soil becomes wet at the top, the water continues to flow down the sand slit and away to drainage, so that ponding does not occur. Let's have a look at what happens when the water is turned off. Here we can see that the coarse sand becomes lighter in colour. It drains quickly, returning the pitch or fairway back to play sooner. Having constructed good, well-connected sand slits, it is important to maintain them with regular top dressing. This next clip shows what happens if regular top dressing isn't carried out and the sand slit becomes capped by the finer material. We can see that again infiltration rate is controlled by the fine material. The sand slit does not work. Instead, the water flows around the slit and ponding takes place. This is to do with soil water potential. The pull of the water into the small dry pores of the fine soil is greater than the push of the water into the coarse sand. When the water is stopped, the ponding disappears, but the surface remains wet. The golden rule is that if you spend thousands of pounds on a sand slit system, you must top dress regularly to keep the sand slit connected with the surface. If it caps, it's useless. Capping is a natural effect of play and even earthworm activity, so you must budget for top dressing. So we have shown that well-constructed, well-maintained sand slit systems are an effective drainage technique, as long as there is connectivity between the surface and the drainage system outfall.